All right, folks, we're going to look here at chemical equations and then how we balance them. We're going to use some M&Ms. Other candies are available to look at a familiar reaction and consider these ideas of balancing. I hope this is of some help. Let's start off by looking at a particular reaction. We're going to do iron and hydrochloric acid making a salt and hydrogen. So let's write this out in the word equation form so it's nice and obvious. We've got our iron plus hydrochloric acid becoming, well, we've got iron plus hydrochloric acid, that makes our iron chloride. And then we've got hydrogen. You can see that I'm actually running out of space on my right hand side, and that's because these word equations are quite big, and that's one reason that we use chemical equations to kind of make things a bit more brief and also to make them a little bit easier to understand in terms of what's actually going on in the reaction and the numbers of atoms, etc. So I'm going to use different colors to identify a few things. We've got iron, so this, my blue is going to be Fe. Okay, I'm going to use red for hydrogen, H. Let me just get a new red pen because that is not very clear. And then I'm going to use my green, somewhat fittingly, for Cl. Okay, we've got Fe, H, and Cl. Let's write out the equation. Okay, let's write out the equation. Well, iron is Fe, and then we're going to add that to hydrochloric acid, which is HCl. We've got Cl. And that all reacts together to produce iron chloride. Now you should have picked up from the reading that iron chloride's formulae is FeCl2. And then we've got hydrogen in there as well. And hydrogen is expressed as H2. Okay, so why are we doing this? The real point here is about the balancing of this equation. This equation is not balanced, okay? And the way we can see this is by introducing our candies at this stage. So let's just count the number of things that we've got, okay? So let's take an example of my iron, okay? I've got one iron over here and one iron over here because my Fe has no subscript. If there's no subscript, then by default, we're looking at one atom of that particular element, in this case, HCl, in this case, Fe, iron. If we then go to the next one, the reds, well, we look at the hydrogen. Well, I've got one on the left, and then I've also got two on the right, because it's H2. If we have a 2 on that subscript, that means we've got two of them. Similarly, for my chlorine, I'm just going to bunch these guys together so that they make sure that we're all part of a compound. We've got this one here. Now, if we do a little bit of a count, okay, if we look, for example, on the left-hand side of the equation, LHS, and then the right-hand side of the equation, we could do a little count. On the left-hand side of my equation, I've got one iron and one iron, so I've got 1 and 1. Okay, I'm doing a little tally here. On the left-hand side of my equation, I've got one hydrogen, but I've got two hydrogen on the right. And the same for my chlorine. Now, anytime that you have different numbers on either side, then we are going to have what we call an unbalanced equation. Now, this equation is actually fairly simple to balance here, okay? If we look here, we don't need to worry about the iron. We don't want to do anything to iron yet, okay, because our iron is balanced. However, what we can do is change the amount of something else, and that something else in this case is going to be my HCl. If I take my HCl, and instead of having just one molecule of HCl, I add another one, then my numbers start to change. I'll have 2 atoms of hydrogen on the left and 2 on the right. I'll have 2 atoms of chlorine on the left and 2 on the right. And in that case, this is balanced. Now, the remaining thing that for me to do here is to adjust my equation. Because this equation is still unbalanced, it hasn't taken into account that change that I've made here. In other words, it hasn't taken into account that addition of the second molecule of HCl. So all I have to do in front of here, I'll just rub out my plus sign, is put a large number 2 in front of that. And then that's called our coefficient. And this allows our equation to be balanced. Both sides have got equal numbers of each atom type on each side.